Okay, now let's start taking some really big numbers and writing them using scientific notation. So here we go. Look at this one. This is over 11 million. That's huge. In fact, 11,700,000. Let's see if we can write that in scientific notation. What's the key? The key is to constantly move the decimal point over until the number we have is bigger than 1 and smaller than 10. So let's see where that's going to be. So, no. Because that number right there, you see, if I put the decimal point there, is 1,170. That's now 117. That's 11.7. That's just a little bit bigger than 10. I want the number to be less than 10. Slide over one more spot. I see 1.17. That actually is bigger than 1 and less than 10. If you want to check your answer, slide over again. It should be wrong. Slide the decimal point to here, and notice I have 0.117. That's actually smaller than 1. I want the number to be between 1 and 10. So the decimal point should be right there. And so I see this equals 1.17 times a power of 10. And now to figure out what the right exponent should be, all I have to do is count how many places over I have to slide the decimal point to the left in order to make it 1.17. 1, 2, 3, 4, 5, 6, 7. Great. So scientific notation of 11,700,000 is 1.17 times 10 to the 7th power. Pretty straightforward.
Okay, let's make sure you get a graphic representation of what we're talking about when we're talking about putting a number in scientific notation. Remember that the rule is you move the decimal point until the result is a number between 1 and 10. In other words, the number should be greater than 1, but less than 10. Greater than 1, but less than 10. All right, now if you move the decimal place one place, this is where you are. This number is greater than 10. If you move it 2 places, this number is greater than 10. 3 places, this number is greater than 10. 4 places, this number is greater than 10. And notice when we're moving, that's 1, 2, 3, 1, 2, 3, 4. See, still greater than 10. 1,170 is greater than 10. All right, let's see what happens when we move it 5 places. Move it 5 places. 1, 2, 3, 4, 5. We got 117. That is still greater than 10. Let's move it 6 places. 1, 2, 3, 4, 5, 6. 11.7. That is still greater than 10. Let's move it 7 places. 1, 2, 3, 4, 5, 6, 7. Now we have 1.17. That number is greater than 1, but less than 10. It's greater than 1, but less than 10. This is where we want to be. Now if we went one more place, 8 places, 1, 2, 3, 4, 5, 6, 7, 8. We've gone too far. Notice we got 0.117 or just 0.11. That's less than 1. Remember, it has to be greater than 1, but less than 10. So here, we've gone too far. And now, since we've counted 7 spaces, we're going to write our answer as 1.17 times 10 to the 7th. Once again, 1, 2, 3, 4, 5, 6, 7. That's where we want to be. So 1.17 times 10 to the 7th. Writing a number in standard notation. To translate between scientific notation and standard notation, move the decimal point, the number of places indicated by the exponent, in the power of 10. When the exponent is positive, move the decimal point to the right and add placeholder zeros as needed.
A lot of times we're going to see numbers in our lives that are expressed in scientific notation, and we want to convert them back to sort of a standard form that we're used to seeing. So let's take a look. For example, the population of Brazil, it turns out, is about 1.86 times 10 to the 8th power people. So that's the number of people. And we want to write this out now as we would normally see the number not written in scientific notation. So what do? What I do is I write out 186, and now I'm going to produce a bunch of zeros afterwards. How many zeros? Well, in fact, as many zeros that's required for me to take that decimal point, and I'm going to move it over 8 units. So notice when I start, I moved it 1 unit, 2 units, and so now I have to keep moving it. So I start here, and here's how I do it. I just start here and start counting. 1, 2, 3, 4, 5, 6, 7, 8. And so my point's right there. And each of these little containers requires a little, like an egg. Like it's like they're like eggs in a carton. But they're really zeros representing a number. And so that tells me how to do it. Notice I started here, and if you count 1, 2, 3, 4, 5, 6, 7, 8, you get it. Now, you have to get rid of the egg carton now, because of course it's not really eggs, it's actually numbers. And so what would the number be? Well, you have to write this out nicely. But once you do, you see that we have 186 million. And that's approximately the population of Brazil. Cool.
Okay, example 2. Write 3.5 times 10 to the 6 in standard notation. Step 1. Use the exponent of the power of 10 to see how many places to move the decimal point. Power of 10 is 6, so it's going to be 6 places. Step 2. Place the decimal point. Since you are going to write a number greater than 3.5, move the decimal point to the right and add placeholder zeros if necessary. So we got 3.5, and we're going to move 6 places. 1, 2, 3, 4, 5, 6. And that's all there is to it. Once again, 1, 2, 3, 4, 5, 6. So the number 3.5 times 10 to the 6 written in standard notation is actually 3,500,000. Once again, 3,500,000.